Before we get a better understanding of a binomial theory or expansion, so let's understand this simple concept here. Now, assuming we want to buy an iPhone, right? That costs just $5, right? This is just an assumption, and then we want to buy 5 pieces of that iPhone. So what it means is that we are going to buy 1, 2, 3, 4, 5, right? So in all, we are spending what, $25 for what, 5 pieces of what, an iPhone here. Now, for us to break this thing down, we can easily use what this method here that says that $5 or squared. So the meaning of this square here is what, 5 times 5, right? So the meaning of this square is what, 5 times 5, which also gives us what, $25 here, right? For us to avoid this long method here. Is that okay? Now, if you don't want to buy a handful, but you want to buy a different item or a gadget here, this is what, X. So we are calling it X here because we have so many different types of what, a product. So someone might want to buy what, a different what, a product. So let's make it a square. So X square here means what, S multiplied by what, X, right? So the same scenario here. Okay, now you go to the market, you want to buy 2 different products. So let's say iPhone and what, and a laptop. Is that okay? So you are buying these 2 things at the same time. So if you want to buy these two pieces of what, this item here is that we are going to square that. So meaning that what, S plus what, Y here. So X is the iPhone and the Y is what, is the laptop here. Squared means what, we are going to what, multiply that by 2, right? So we are going to expand that into what, 2 form, just like in the case of what, this guy here, right? So in the case of this guy here. Now the idea is that this is just a square, right? This is just a square. So if I tell you that this is just a $5 and this is also what, let's say $4 here, you can easily find the 2 pieces. Is that okay? You can easily find that 2 pieces. Now what will happen if you want to buy 7 pieces, 10 pieces, 100 pieces in all, right? So maybe you are going to open a shop. What do? That is where you need what, a binomial theory. Is that okay? So that is where you need what, a binomial theory or a spatial. So how do you use that? There's a trick here, a method here that is called a Pascal triangle. I will demonstrate that in the next video. Is that okay? So you have to use a Pascal triangle to do that. So if this is being raised to the power into 7, so you are going to buy this in how many times? 7 times. So if here is what, 10, here is 20, here is 100, then you cannot expand it in this way, right? You cannot expand that in this way. That is why you need something called a binomial expansion or binomial theory. So the one method is what, a Pascal triangle, and then we will do that in what, in the next one. So the importance of a Pascal triangle is to help us expand this thing, right? Something of this nature. So the traditional way of doing this thing is to do this thing what, 3 times, expand this bracket or 3 times. So a plus b multiplied by a plus b multiplied by a plus b, right? So that's the traditional way. So I've already given a scenario on how to understand this thing better using iPhone and what, and a laptop, right? So suppose this is the iPhone and this is the laptop here. Now we want 3 times, maybe 3 group of what, this guy here. So the concept of what, a Pascal triangle is to help us determine the number, right? The number, look at the number that will be attached to this guy here, and I'll explain this guy in just a few minutes. Now what it means here is that for you to have the idea of a Pascal triangle here is a plus b. This is what we are having here, a plus b exponent 3. So let's use what, exponent 3 here, the index here, to demonstrate the example. So here you are going to start with whatever is here first, right? So whatever is here first, that is the a here. So a exponent 3, whatever the exponent is, right? So a exponent 3 here, and then followed by what, b, right? So let's focus on the first part. So if you are dealing with the first part, whatever is here, right? So that is what, a3, this 3 is coming from the exponent here, right? This and this are the same. Is that okay? So we are starting with this a exponent 3 here, and then if you go to the second term here, a exponent 2, obviously that this guy is descending, right? So a exponent 2 here, and then here is a exponent 1, and then finally you get to a exponent 0. Is that okay? So once you get to the 0, then you are starting with the b. So what I mean by the b here is that anything that is here. Is that okay? So that is just the arrangement. This one will go forward and then this one will come back. So someone goes like this and then the second person also goes like this. So here we are ending with the 0, the exponent 0. So the second part will start. So the b will start from here. Is that okay? So the b will start from here. So the exponent is what? 3. So this 3 is coming from this exponent. Is that okay? So this 3 is coming from this exponent here. So b exponent 3 and then b exponent 2 and then b exponent 1 here, then b exponent of 0. Is that okay? So those a and b can be any number, right? Any number. We will look at example very soon. So that is the first arrangement, first part of the Pascal triangle. Is that okay? So these two guys is what we are dealing with now. So the one go forward and the other one comes back. Now it's so attempt to know which number will be attached to these guys here. So the numbers here is what we are going to use what a Pascal triangle to determine that. Is that okay? We are going to use a Pascal triangle to determine the number, the friends that will attach to these people here. So mathematically, that is the coefficients, right? So let's have a look at that now. This is the trick to determine what the Pascal triangle, right? So the triangle, the coefficients here. So we start with the 1, right? So the 1. So 1 at the top here. So 1 at the top here. So how do you get to the next one? So this 1 here gives me exponent 0. So if you're having anything be raised to the power exponent 0, right? So we are going to suppose here the number, the index is 0. So this is what the first coefficient here. So here is what exponent 0, here is what exponent 1, here is what exponent 2. But how do you determine this? So here we assume that there's nothing here. So 0 plus 1 here will give me 1. Look at where 1 is. And then this 1 plus another 0 will give me 1. Is that okay? So leave some space here. So this is just a simple arrangement, right? So on the next line you have a 0 plus 1 here. That gives me a 1. Look at where 1 is. And then 1 plus 1, right? 1 plus 1 will give me 2. Right, so 1 plus 1 will give me 2, and then 1 plus 0 will give me what? 0 here. Is that okay? Just look at the arrangement. That is what we call it. The shapes looks like what? A triangle. Now if you go to this line here, you can see that this 0 plus 1 here will give me 1 here, right? And then 1 here is what? 1 plus 2 will give me what? 3. Look at it. 2 is at the middle, right? So 3 here is at the middle, and then here we have what? 2 plus 1, that will give me what? 3, right? So 3, and then 1 plus 0 here, there's nothing, a 0 here, that should give me 1. And so on and so forth. This is very simple. So when you go to this line, you can see that here we're having a 0 plus 1 here, right? 0 plus 1, that should give me 1, and then 1 plus 3 here, that should be 4, and then what? 3 plus 3 here, that should be 6 at the middle, right? And then what? 3 plus 1 here, that should be what? 4, and then 1 plus 0, that should give me what? 1. So the same thing, right? The same thing. All that matters here is that the arrangement is 0. So in our case, we are dealing with exponent 3. So okay, exponent 3. So we will be on this line. So these guys will be what? Our coefficients. So the coefficients are what? 1, 3, 3, and then 1. So okay, 1, 3, 3, and then 1. So all that matters is after arranging everything here perfectly, so you just need to attach the coefficients. So which is what? 1 here, and then here we are having what? 3, and then here we are having what? 3, and then here we are having 1. Is that okay? So that is what the simple expansion. But remember, don't forget, one thing you have to pay attention to here is that look at this example here. We are having 2x minus what? Negative 3, exponent 3. The same idea. Anything that is here is your a, and then anything that is, especially if you are having a negative, right? So that is your b. Is that okay? So make sure that you write these guys along. So we are dealing with exponent 3. The same thing. So the coefficients here will be 1, 3, and then 3, and then 1. Now you proceed from here. So these guys exponents what? 3 here will give me, I think this will be what? 1, 8, s exponent what? 3, and then that raised to the power 0 will just be what? 1. Is that okay? Very simple. Now let's see how we can use the Pascal triangle to solve this type of problems here. The question says we should write the binomial expansion of 1 plus x exponent 4. So the idea here is that the trick you are going to use a Pascal triangle to expand this. You can see that this is what raised to the power exponent 4, right? That is very tedious if you want to go by step by step. So how can we use the Pascal triangle to demonstrate that? We know that to expand the Pascal triangle, you have the first guy here, right? Raised to the power 4, right? The power being given to you, and then multiply by what? The second guy here raised to the power 0. So where this guy starts with the exponent, right? So this guy is 0. Is that okay? So that's just the trick here. So where this guy, the first guy, starts with the exponent being given to you. So of course this thing has to be a positive exponent, right? And then here is s, the second guy here is being raised to the power 0. So where you start, that is where I end, or where you end, that is where I start. Is that okay? Now so let's focus on these two guys in the bracket first before we come to the coefficient. That is where we need the Pascal triangle to give us the coefficients directly. Okay, now that this guy starts with the exponent 4, and then this guy also goes to s exponent 0. So on the second term, you are going to have a 1, which is the first guy here, right? The first guy exponent 3 here, and then this is also raised to the power s exponent 1, right? So this guy starts from 0 to 1, and so on and so forth. And then this guy also starts from what, exponent 4, and then keep on descending, right? So this is what, exponent 4 here, and then here is what, 3, here is what, 2, and then here is what, 1, and then here we are going to have what, 0 here. Is that okay? So I've already demonstrated that in the Pascal triangle. So if you are not that okay, make sure that you just go back and go and check that. Okay, so these are the guys that you are having. So how do you get the coefficient? So the coefficient guy here, with the help of the Pascal triangle, we are going to use that is being raised to the power exponent 4, right? So you remember that this thing starts from the Pascal triangle. The first line starts from 0, 1, 2, 3, and then 4. So you'll be on what, the fifth line. So right, you'll be on the fifth line from the Pascal triangle. So what is the coefficients? The coefficients are what, this guy here, 1, right? You can just go back and go and check the Pascal triangle. So this is 1 here, we are having 4, and then 6 here, then followed by 4, and then finally we have what, 1. Is that okay? So this is what, very simple. This is very simple and straightforward once you understand how the method works here. Now the next line is that you have to expand everything, right? You have to do your calculation. So let's see how to do that calculation here. This one, we are not going to do anything to the 1 here. So 1 exponent 4 here will give me 1, right? And then anything raised to the power 0 is still 1. Is that okay? So anything 1 billion raised to the power 0 is still 1. So here we are having 1 here, 1 here, and then 1 here. So 1, 1, 1. And then when we go to the second term, we have our 4 there. 1 exponent 3 is still 1. And then x exponent 1 is what? Just x. So when you go to this line, you are going to have your 6. 6 is there. 1 squared will give me just 1. And the x squared is exactly what you are having here. So here we are having our 4 here. And then here we are having 1 exponent 1, which is 1. And then x exponent 3, that's also what we are having here, right? So the same applies to the latter part. Here we are having 1. So 1 raised to the power 0 is still 1 here. And then x exponent 4. Right? So just do everything step by step. Don't be in a hurry. No one is chasing you. Okay, now let's move on. So 1 multiplied by 1, then 1 times 1 times 1, that will just give me 1, right? So here we are going to have 1 here, and then here we are having what? And then 1 multiplied by 1, 4 multiplied by 1, which is 4 here, and then times x, that will give me what? 4x, right? So that will just be what? 4x there. So when you get to this line, this is what? 6 multiplied by what? 1, that is what? 6 here, and then x squared. So we are going to have what? 6x squared. So the same thing applies to the rest of the two guys. Is that okay? So you are going to have something very nice. So if you simplify, we are not simplifying anything tedious or bad here. So just this guy, 1 multiplied by x is just giving s exponent 4, right? So 1 multiplied by what? S exponent 4 is what? S exponent 4. So you should have, this is what our binomial expansion, that is what? 1 plus what? 4s plus what? 6x squared plus 4s exponent 3 plus what? S exponent 4. Is that okay? So this is very simple. This is a very nice method in what? Expansion. So thanks to what? Pascal. Okay, now the second part says that we should evaluate what? We should use this result. That is very important. So we are going to use this guy here to evaluate 5 over what? Over 4. Everything raised to the power 4. Is that okay? So look at something. The trick here is that they say you should use this. So you must make sure that this guy looks like something that is similar to the question being given to. This is 1 plus s exponent 4. Once we are able to rewrite this guy here, which is 5 over 4 exponent 4 here, into this guy, we are free to go. So our work here is that this is being raised to the power 4, and then from the question what they gave us is also raised to the power 4, right? So now it's just whatever is in the bracket, that is what we are looking for. So you have to rewrite this guy. This is fraction. So change this guy to a decimal, right? You can use a calculator or you can easily expand this thing. Okay, so if you rewrite this thing to a decimal, you're going to have 1.25, right? So 1.25 here. Okay, this 1.25 here can also be written as 1 plus 0.25, right? So the reason is that the reason why we are doing this, we want something that looks similar to what has been given to us, because we know the answer to this, right? We know the root to this guy here. So once you look similar to something that looks like 1 plus something here, we are free to go. Is that okay? So that is exactly what we had here. So 1 plus 0.25. So you can see that our 1 is a constant from the question here, and then 0.25 will be our x, right? So this is what we are given. Is that okay? So our 1 is, so we are grateful that we had 1 there, and then plus x. So our x here, that's the only thing that is missing. So the x here will be 0.25, right? So here we are having what, 1 plus of x, right? Everything raised to the power 4. Is that okay? Everything raised to the power. So our s here is 0.25. So whenever we see the x, so since we know the solution to this guy, right? We know the solution to this guy. That is 1 plus 4s plus 6s squared plus 4 exponent 3 plus s exponent 4. That is the solution to it. So whenever we see the x here, we can replace that with 0.25. Is that okay? Look at, they have to look similar. Is that okay? So this one is there, the plus x, which is plus 0.25, and everything raised to the power 4. So we are just going to replace, right? So wherever you see your x here, replace that by 0.25 there. So 1 plus 0.25 exponent 4 is equal to 1. This 1 is coming from this 1 here, the solutions that we had, and then plus 4, right? Plus 4x, right? Plus 4x, our s is 0.25. Right, 0.25, and then plus there is 6x squared. So we know that the x squared is 0.25 squared here, right? So the s squared is 0.25 squared. So the same thing. So whatever you see the x from this guy, you just replace that with 0.25, because you've already expanded that 5 over 4 into 1 plus 0.25. Is that okay? So now we are free to go. So you just need to do your calculation. Very, very simple. You just need to do your calculation, expand everything perfectly, then you should get something like 1 plus or everything. That is 0.02625, and so on and so forth. So you just need to add this guy. You should have something that will be similar to 2.441406. From the question, they say you should round out to 3 decimal places. So these are first decimal place here, second, third, right? So once that the next guy is not up to 5, then you leave it as it is. If you don't know how to round this thing on a decimal, just make sure that you subscribe to the channel. You have a full video on that, right? Okay, now here's a similar question, right? This is so similar, so I guess that you should pause the video and try this. Is that okay? Just pause the video and try it. So you are going to have 2s plus 1 exponent 4. And then they say you should expand this thing with the binomial expansion, right? So you expand the bracket here, so and then evaluate 1.05 exponent 4. They say you should evaluate this. Is that okay? So once you expand this thing, then you can easily evaluate that. So this thing can just, let me give you the clue here. This thing can be written as 1 plus 0.25 exponent 4, right? So once you have your answer similar to the one that we just solved, you just need to replace your x by 0.5, and then write the answer. If you enjoyed the video so far, don't forget to subscribe. Let's have a look at the second question here. Okay, the question says that we should simplify and leave the answer in a set form. So this is what you have. You have root 3 plus or root 2, everything raised to the power 3, and then plus or root 2. So the only difference is there yes for addition and yes for subtraction, but it's being raised to the power of 3, right? So this is not square. If it is square, we can say that is very easy to go about. So being raised to the power 3, here we are going to use a Pascal triangle. So with the help of the Pascal triangle, we can easily expand these two guys, right? Okay, now that we know that the Pascal triangle being raised to the power of exponent 3, you must know the coefficients, right? So have your Pascal triangle down. You can always go back and go and check the Pascal triangle. Okay, so this is what exponent 3. Remember that the Pascal triangle doesn't start from 1, right? So if you have 1 here, let's say what I mean by that is you have 1 here. So the next line will be 1, 0 plus 1 here, that's a 0, and then 1 plus 0, that's still 0. So 0 plus 1, that should be 1, and then 1 plus 1, that should be 2, and then this plus this, that should be 1, right? So this guy here is the exponent 0. This guy is exponent 1, and then this guy is exponent 2. Then you have to go like that. So the key here is that it starts with 0. It doesn't start with 1. That is the index, right? So the exponent starts with 0. Okay, now that we know that, let's look at the exponent 3. So this is very easy. So just similar to that, all that matters is that you have to know the first guy and the second guy. So let's consider this guy first, right? So let's consider this guy first. So we are going to have the first guy here. We know what to do. This is the exponent, right? So this is the exponent here, which is 3. So this guy takes the first exponent, so root 3 exponent 3, right? So the next guy starts from 0. Is that okay? So the next guy is root 2. So root 2 exponent 0. right? So the same thing and so on and so forth, similar to the one that we just saw. The only thing that is changing is that we are dealing with what? Square root, right? We are dealing with what? Set. Okay, so the coefficients of what? Exponent 3 here should be what? 1, 3, and then 3, and then 1, right? So these are what the coefficients. The rest are just what? Increasing and what? Decreasing order of what? The index. Is that okay? Now, okay, the next line is that you have to know how to expand the what? The set here, right? So this guy being raised to the power 3 will give us what? 3 root what? Root 3, right? So if you don't know how to multiply, make sure that you subscribe to the channel and see how to multiply set, or with the help of the calculator in some cases. Okay, so here we are having 1 here, which is the coefficient. So this guy being raised to the power 3, that should be 3 root 3. And then remember I said earlier on that anything raised to the power 0 is 1. So this guy raised to the power 0 is 1. So here to the same thing, this guy square will give us what? 3, right? And then what? Root 2 exponent 1 will give him what? Root 2. And then the 3, which is the constant, is there. Okay, so this is how you have to expand everything here, right? So if you are having any difficulty, make sure that you comment down below, right? If you are having a different answers or you want us to help you more on this topic, make sure that you comment down below. Okay, now let's move on. If you expand everything, then you just need to multiply, right? Do your multiplication. 1 multiplied by this, and then times 1 give you 3 root 3, right? So you have to have you are going to get something that's a little similar to mine, right? So 3 root 3 plus 9 root 2 plus 6 root 3, right? 6 root 3 here. Is that okay? 6 root 3 here, and then plus 2 root 2. Okay, perfect. Now at this point you should know how to add, right? You should know how to add a set. How do you add? You add those that look similar. So what I mean by that is that a number under the set, if you want to add or subtract, we have a link on this thing. So make sure that you subscribe to the channel. Is that okay? So if you want to add instead, you have to check the number under the radical. So this is what we call a radical. So the square root sign is what we call a radical here. So the number here, you have to look for the number that looks similar to this one. So you have to have a root 3 somewhere before we can combine the two. So here you can see that I say grouping. So we are going to group. This is what? 3 root 3. So I have another root 3 here, which is what? 6 root 3. So let's group these two guys, right? So that is how we had. So let's group these two guys, and then let's group what the 2 as well. So that is what? 9 root 2 plus what? 2 root 2. So how do you add? Since this guy and this guy are the same, you just add these two people, right? You just add these two. That is 3 plus what? 9. 3 plus 6, so that gives me 9. Is that okay? Because these two guys are the same. If they are not the same, you cannot add. Okay, or you cannot add, or maybe in some case you cannot add and subtract as well. So that rule applies to the addition and the subtractions as well. Okay, so this guy plus that guy, right? So this guy plus that gives me 9. Here to the same thing, we are having 2 here. So they are friends. Is that okay? They are friends or they are siblings. So this guy and this guy can be added. So 9 plus this one, that gives me 11 what? 2. Okay, so perfect. So this is for the, just the first part of the question. So this is for this, and then you have to do the same thing for the second one. So the only difference here is negative. So make sure that if you are expanding, don't ignore this negative. It's the first guy and then the second guy. So the first guy is what? Root 3 here, and then the second guy is what? Negative what? Root 2. So the same thing here. You just need to replace this guy with a negative. Right? So negative and then negative and so on and so forth. So pause the video and expand that, right? Just pause the video and expand and come back and come and check the answer. Okay, so after expanding and what? Multiply and do your calculations similar to the one that we just saw with the additions one. And then you should have your answer to be what? 9 root 3 negative 11 root 2, right? If you are having different answers, don't worry, just comment down below, right? Just comment down below. Okay, so here we are going to have 9 root 2 negative 11 root 2. So remember the question says you should add, right? So we are going to add this guy and then that guy. So it means that we are going to add this and that, right? So how do you add? You know how to add already. So this guy is the first one and then plus up the second guy. Is that okay? So you need to group, right? You need to group. So that guy and then that guy is here, and then that's 9 root 3 and then plus 9 root 3, right? And then the 2 also goes to one side. That is 11 plus 11 root 2 and then minus 11 root 2. So we can add these two people here since this guy and that guy is the same. So this plus that should give me 18, right? 18, and then you repeat the root 3, and then 11 minus 11 should be 0, right? So the answer to this is 18 root 3. So thank you for watching.